Hi everyone. In the given problem statement, we have to find the minimum in a rotated sorted array. We have previously solved a problem where we have to find a value in a minimum sorted array. Here, suppose you are given an length n of sorted array and we have to find what would be the minimum value out here. And we have to write the algorithm in big O of log n time so we can clearly understand it's going to be a binary search problem. So here, right, take the example, right? 3, 4, 5, 1 and 2. We can do one thing. Let me write the algorithm, right? We can create a result value. Initially, let me assign it with the value of num of, or let me just say num for now, num of 0. Initial value is 3. Like a binary search, we are going to have our left and right. So left is going to be 0 and right is going to be length of num minus 1. Just ignore the spelling error. I'm just writing a pseudocode out here. So while our left is less than equal to right, the first thing we are going to check, right, if nums of L is smaller than nums of right, then we can say res equal to minimum of current value of res and nums of L and break. So this can happen, right, if in case the array is in the sorted value, right, 1, 2, 3, 4, 9. So here, right, in the first case, right, the 0 is smaller than 9. So we can easily say, right, the res equal to minimum of res by L. But let's say take this example, right? In this case, right, it is not going to be the case. So here we can say, right, let us take this example. 3 is greater because it's an rotated sorted array, right? So it would be greater. Now we can find our mid value. So mid, as we know, right, we have to find by L plus R divide by 2 if nums of mid is greater equal to our and also, right, once you have done that, there would be another value of res equal to minimum of res and nums of mid. If it's greater or equal to nums of L, in that case, what are going to do? L equal to mid plus 1, or else, if it's not the case, R equal to mid minus 1. At last, we are going to return our res. Let me just track it down, right? So initially, res value is 3, L is at 0th index, and R is at 4th index. So our mid would be at here. Okay. So on the first case, right, this is not working. So we are not going out here. Here, the value of res, right, we are in this part. So is 5 smaller than 3? It is not smaller than 3. So nothing is going to happen. Now we are going to check, right, if our mid is greater than or equal to nums of L, which is greater than or nums of L, right? So our L pointer would be at here. So it should be at 3 right now. So once it's at 3, right? So we are going to find, so 3 plus 4 is 7. 7 double divided by 2, it's going to be 3 only. So both L and mid, right, are at this position right now. Now I am going to check, is L less than R, which is true out here, right? L is less than the R value. So here, right, you can break it up, and the res value, right, is 3 is smaller than 1, so the value is going to get updated by 1. And here also, right, if I just come here, so we can easily found, right, it's lesser than the value, so we can just return it up. And once that is done, right, we are able to see that the value is greater equal to, so it would be on that position itself, and it is going to work out. So we are going to get the result, which is going to be return 1, which would be the output. Now let us jump to the Python solution, where I'm going to write this entire code and show how it works. Hi, the first thing that we're going to do, we're going to create a variable result, which is going to store the first value, and this would be an initial value that we're going to have. Now we are going to create our left and right value. So left is 0 as usual, and length of nums minus 1. Now we are going to check while L is less than equal to R. Now we are going to check if nums of L is less than nums of R, then we are going to say res equal to minimum of the current value of res or nums of L. And if you're able to find that value, we can break out of the loop. Else we are going to find the mid. So mid, as we know, is going to be L plus R double divided by 2. And here again we're going to check for the result, which is going to be minimum of result and nums of mid. Now we're going to check if nums of mid is greater than or equal to nums of L. In that case, what we are going to do, we are going to say L equal to mid plus 1, else it's going to be R equal to mid minus 1, and we are going to return the result. Let me run the public test cases. Let's see how it performs. As you could see, the public test cases passed, and let me submit the code. As you could see, the code ran successfully and it is passing all the test cases. That's all for this video. See you in the next one.